I wanted to go over this example and how we can use a z-score to calculate the area under the curve without using a calculator. Later on, I'm going to show you how to do this with a calculator, but just using a table. So the question reads, what proportion of people have IQs less than 105? Shade the region of the graph that shows the probability or the area less than 105. So if you look at the normal curve, we know that the mean is 100 and the standard deviation is 15. And we're going to calculate a z-score. Now, if you remember, the z-score on the previous slide is basically the observation minus the mean over the standard deviation. So the observation we want is right here. We want the area less than 105. So if I draw 105, it's going to be somewhere between 100 and 115. Anywhere you draw 105 is fine, but it is closer to 100. So I'm going to go ahead and draw where 105 would be approximately in, and then it says shade to the left. So I want the area on this curve that is 105 and less, because right here it says where x is less than 105. This is where x is 105, but I want the area less than 105. And we want to calculate where that z-score is. Now keep in mind, the z-score of the mean is always going to be at 0, and one standard deviation to the right is 115, and a z-score, that would be 1. Two standard deviations to the right, that would be 2, so a z-score of 2, and this would be a z-score of 3. And on the left, this would be -1, -2, and -3. And of course, in class, I will go over this more in detail. So I can see that even before we calculate a z-score, that our z-score is going to be somewhere between 0 and 1. So we use a table or a calculator when our z-score doesn't fall exactly on the observation that we want. So how do we calculate a z-score? Well, it is the observation, which is 105, minus the mean, which is 100 right here. So minus 100, and this is from the normal model given previous slide. And the standard deviation is 15. And you could see we are counting by 15. If I reduce this fraction, we get, this is very simple math, I'm just going to get 5 over 15, which is basically equal to 1/3. And 1/3 is about 0.33. So about 0.33. Well, this is our z-score. Our z-score is 0.33. And this makes sense because I can already see from where we drew over here that this line right here corresponds to a z-score between 0 and 1, a little bit closer to 0. So 0.33 is between 0 and 1, so that makes sense. Now, what is the area in this region? Well, because we can't use the empirical rule, we can only estimate it. We can use this table to look up what the area is for a z-score of 0.33. Now, what you see here in this table, that is the area under the curve. So you could see that a z-score of 0 right here, a z-score of 0.0 just means that is 50%, which makes sense because half of your observation is 50% below the mean and 50% above the mean. So if I want to look up a z-score of 0.33, well, 0.3 is right here, and 0.33, I will just go to the fourth column right here, 0.33. So going down here, the corresponding decimal right here, if I drew across from 0.33 is 0.6293. So 0.6293 is the area under the curve that I shaded here to the left of 105. But if we convert this to percentage, that would be 62.93%. So the proportion of people who have IQs less than 105 would be 62.93%. And we'll do more examples in class when I see you.